Okay, so today we are going to cover RL series circuit. Last lecture we have covered the AC circuit with R only, L only and C only. Now we are combining for the first time RL series circuit. So write down please RL series circuit. Write down the topic RL series circuit. So basically we are considering the circuit as follows. We have a resistance in series with an inductor. Alright, we consider a pure inductor and we have this AC source. So over here, this is my R, this is L, and this is my supply voltage V given by Vm sine omega t. Alright, it's a AC voltage. So whenever there is a AC voltage, there is a AC current flowing through the circuit, which is represented by, let's say, I. So this is the current I. Remember, this capital I is the RMS value, not the peak value. Now, whenever the current flows through a resistor, there will be a creation of a voltage drop, right? So this voltage drop is VR. Okay? And over here also we have a voltage drop across the inductor. This voltage drop is called as VL. Alright? Now tell me, factually, what is VR given by, according to Ohm's law, even if it is a AC current or AC voltage? VR will be this current I into this R, right? So it will be I into R. Now again factually tell me what will be VL. Current into, see, this is a resistance, right? Opposition to the flow of current. For an inductor, what is opposition to the flow of current called as? Z. And what is Z? We have found out inductive reactance XL. So VL will be I into XL. Did you got it? Did you understand this? We have discussed this last time. And what will be total V? Yes, correct. Opposition to the flow of AC current is Z directly. I into Z. So these three things you should remember. So kindly note it down. No need to note down the theoretical statements which I have written over here. That is, after you go through the handouts, you can understand it very clearly. Alright. Okay, so we'll only write whatever I'm writing, only you write that much. So consider a resistor R of value ohms and an inductor of value Henry connected in a series across the AC supply. So the voltage over here, V is the RMS value of the applied voltage, I is the RMS value of the circuit current, and Z is the impedance of the circuit. Z is called as the impedance of the entire circuit, RL series circuit. Okay, and this is my RL series circuit. All right. Now let's go further. By Ohm's law, what can we, whatever we have written over here above, we write it over here if you have not written it yet. VR will be I into R, VL will be I into inductive reactance XL, and V will be I into Z. That just now we have written, right? If you have not written it, please write it down. Okay, if it is a resistor, what will be the phase difference? Here. So VR, we can say, is in phase with current. Just VR, voltage across resistance, will be in phase with the current. Why? Because there is no phase difference if you consider only resistor. Now, if you have an inductor, you remember what happens? Your voltage, what happens to the voltage in that inductor? Current lags, right, behind the voltage. So the voltage will lead the current. So VL leads current by 90 degree. This we have learned with the analysis of AC circuit with inductor alone. Okay. Now obviously V is the total applied voltage. So if we go by vector form, we have to draw the phasor diagram. So how can you write V? V bar will be is the summation of, it will vector sum of VL plus VR. Yes or no? So how will you do it? So let's come to phasor diagram. How will you do it? Let's say x-axis over here is my, let me draw the x-axis. Let's say this is I. This is I. Alright? Current I. Now tell me where will be VR? VR I am marking in blue color. Where will be VR? In phase, right? In phase with the current. In phase with the current. This is VR. Agree? Where will be VL? VL is leading the current by 90 degree. So if I draw VL over here, am I wrong? No, it's correct. So this is VL. Are you understanding? So where will be V? Here, left out. This will be V. I am marking V in green color. This will be V. Agree? So this is V, which is I into Z. This is VR, which is I into R. And this is VL, which is I into XL. Got it? So this is the phasor diagram. And what is this? Phase angle phi. Understood? So please draw the phasor diagram. First you draw current as a reference. So current is drawn as a reference. Everyone understood how we have got this? So this is the phasor diagram for RL series circuit. Alright, this is the phasor diagram. Now there are three triangles: voltage triangle, impedance triangle, and power triangle. You need to understand them thoroughly. It's there in module number 2.3. We need to understand them for RL series, RC series, RLC series, then parallel also. So please understand thoroughly. So here on the right hand side, I am drawing the power triangle. So how will you draw? No, voltage triangle. Do you see three voltages over here? V, VL, and VR. So just that only we have to draw alone. Okay. So please draw along with me. So it will be like this. I mean, if you want to show in vector form, you can. So this is phi. This will be VR, which is I into R. This is VL, which is I into XL. And this is V, which is I into Z. This is called as voltage triangle. Got it? Just an extension of your phasor diagram only. So please draw the voltage triangle. What is phi called as? The phase angle of the circuit. Okay, you know trigonometry, right? I mean, obviously you all are living it. Okay. So tell me, what is tan phi from this voltage triangle? Tan theta is VL upon VR. Just remember this, this will be useful somewhere. And what is cos phi? VR upon V. So please remember this. This where you got it from, the trigonometry of the triangle, voltage triangle. Now, can you say from the phasor diagram, the current lags behind the applied voltage V by phi? See, the current I lags behind the applied voltage V by phi, where phi is less than 90 degree. Did you understand? Meaning I am talking about this V and this I. So this current I lags behind the voltage, applied voltage V by an angle phi, which is less than 90 degree, right? Okay. So this is the observation. So you have written it. So same thing I have written it over here. So whenever a current lags behind the applied voltage by an phase angle, what is the nature of the circuit called as? Inductive. Whenever we have said that, right, in an inductive circuit. So whenever the current lags behind the applied voltage, the nature of the circuit is inductive. Alright, so therefore it is an inductive circuit. What is tan phi? Just now you have told me, right? What is tan phi? VL upon VR. So what is phi if I want to find out? Phi will be tan inverse of VL by VR. Now what is VL? I into XL, and VR is I into R. So can I say that is phi is equal to tan inverse of XL upon R? This is also the formula, right? So please write down this. Where we got this from? We got this from the voltage triangle. Please write along. Next is power factor. Power factor is cos phi. What is the cos phi you all told me? What was it? VR upon V. So it will be I into R upon V into Z, right? Yes. So please write down V into Z, and that will be, sorry, I into Z. V will be I into Z, and what do we get it? R by Z. So power factor will be R by Z. These all formulas will be used in your numericals. So will it be a leading power factor or a lagging power factor? For an inductive circuit, it will be a lagging power factor. So power factor is lagging. Why? Because as the current I lags behind the applied voltage, therefore the nature of the power factor is lagging. Whenever the current lags behind the voltage, it's lagging power factor. Whenever current leads the applied voltage, it's leading power factor. Okay? Noting it down? Alright? We have learned phasor diagram, we have learned voltage triangle. Now we will learn impedance diagram, impedance triangle. So write down impedance. So the total opposition to the flow of AC current is Z, right? So in the voltage triangle, what is a voltage triangle? Can I draw it? Voltage triangle over here. So this is my voltage triangle. So in the voltage triangle, we used to write now IZ. This is I into XL. This is I into R. In the voltage triangle, divide all the segments divided by I. So what do we get? If I divide by I, this I will be gone. This I will be gone, and this I will be gone. This become impedance triangle. So write down. Draw it, please. This is impedance triangle. This is phi. This is 90 degree. This is called as impedance triangle. How do we got it? Divide voltage triangle, each voltage phasor by I. Impedance triangle. Are you following? Yeah? Remember, understand one thoroughly. Similarly, we have RC and then RLC. So there will be a lot of confusion. So understand one thoroughly and then you can go to next. Understood how we draw the impedance triangle? So please draw impedance triangle. And ahead, do you know Pythagoras theorem? What is it? What can I write Z square as? R square plus XL square. That's it. We will be using this also. So write it down, please. Needless to say, it is by Pythagoras theorem. Okay? Completed? Can we move on? So, from the impedance triangle, Z is R square plus XL square, the whole raised to half ohms, correct? So please note down this formula. Now we have to express this impedance in terms of rectangular and polar form. We have to express this Z in terms of rectangular and polar form. How will I represent Z as? So tell me, how will I write Z? Z is equal to R plus J XL. This is rectangular form for RL series circuit. R plus JXL. And what will be the polar form? Z is equal to Z. This is Z bar actually. Z bar is equal to Z angle phi ohms. This is polar form. Let me write over here. This is rectangular form. This is polar form. So you can express impedance in terms of rectangular and polar. Now tell me, what is Z? What is this Z called as? square root of r square plus xl square. And what is pi? Tan inverse of xl by r. Just now we have derived, right? So write down where z is given by square root of r square plus xl square and phi is given by tan inverse of xl by r. Got it? Understood? You have noted down? Okay. So next we go for power. Now we have to draw the power triangle. We have drawn the phasor diagram, the voltage triangle, impedance triangle. Now it's the turn for the power triangle. So write down power. Don't write down this wordings, just wait. Write down the topic power. Now there are three types of power. Now listen very, very carefully. This topic is going to be repeated many times, but in detail I am telling right now. Power are of three types in a circuit. So the first power is called as active or true power. The power that is actually consumed in the circuit is called as active or true power. Write down the first case, active or true power. You can leave some space for definitions later, but only write the heading active or true power. In case of R, in case of resistance, whatever is the power consumed by the resistor, it's true power. True or active power. Understood? Power that is actually consumed in the circuit is true power. Then, the circulating power is called as reactive power. In case of L and C, there is circulating power, which is called as reactive power. So second, write down reactive power. Written? Okay? I'll explain what is reactive power, just wait. In case of resistance, current I is in phase with voltage? Yes or no? In case of capacitance or inductance, current I is 90° out of phase. I'm not saying leading and lagging. I'm just saying current is 90° out of phase with respect to voltage. Now, what will be active power given by in case of AC circuit? Anyone? Active power will be given by V into I. And reactive power will be given by V into I. But there is difference. Active power is with respect to resistance. So your current over here is in phase with voltage. Okay, and your current is 90° out of phase with voltage. This is not the final formula. Active power, reactive power ka formula is not the final. It's the concept which we are building. Active power is V into I, where current is in phase with the voltage. Reactive power is V into I, where current is 90° out of phase with the voltage. Now I told you know what is a circulating power. So just listen, just read the statement. I told you the instantaneous power consumed in an inductor or a capacitor is zero. We have proved that. Right? There is average power, but instantaneous power is there, sorry. Average power is zero. Why average power is zero? Because in a pure inductor or a capacitor consumes no power because the power received from the AC source in a half cycle is returned to the source in the next half cycle. So whatever actually what happens is consider a AC waveform. For a positive half, capacitor stores the energy and the negative half it returns back the energy. So on average over a one cycle, the total power consumed will be zero. So this is called as circulating power. What it is there, it is required. Without it, we cannot do it. But is it the real power? No. The active power or true power is different. So it is there, we cannot eliminate it. And what this is called as, the circulating power is called as reactive power. Okay? Understood? Don't write the definition. There is third type of power. First power is active, second is reactive, third is apparent. And what is apparent? It is a product of voltage and current in an AC circuit. Okay? It is a product of voltage and current in an AC circuit. Please write down the third type of power. Just a name write down. That's it. You remember we have taken current as a reference. Now we take voltage as a reference and we draw the phasor diagram. So now tell me, how will you draw it? So this is my voltage V and I am supposed to draw current now. So help me out please. Current is in the, how will you draw the current now? In the earlier diagram, what did we say? Current was lagging behind the voltage by, here we have said na, current lags behind the applied voltage by phi. Okay. So this is voltage, where will be my current lagging behind by phi but less than 90. So current will be somewhere around here. ऐसे रहेगा current. This will be I. Or let me draw it more thoroughly like this. Now इसका x component will be what? I cos phi, and y component will be I sin phi. Got this? And how we have drawn this diagram? Because we know that the current lags behind. So lag matlab piche. And it's less than 90 degree. So less than 90 degree meaning this. So phi over here is less than 90 degree. Got it? This is also phasor diagram taking voltage as a reference. So this is also a phasor diagram. Please draw this phasor diagram. Taking voltage as a reference. So basically a current component I, your current component I, is resolved into two components, I cos theta, I sin theta. So I cos theta is in phase with the voltage, is in the same phase with the voltage, and I sin theta is 90 degree out of phase with the voltage. Okay. Now this let's call this as figure number 1. So if we multiply in this diagram, if we multiply each current vector by V, remember carefully what I am saying. In this phasor diagram, if we multiply each current vector by V, we get a power triangle. If everywhere we multiply by V, so what it will become? Vi cos phi, Vi sin phi, and V into I, right? So I draw it please. So what I mean is this, let me use a blue color. Okay, so I'm drawing this diagram again. You can show vector also, no problem at all. So what I said, this was I cos theta, right? Cos phi. So I multiplied by V. This was I sin phi. So I multiplied V over here. So what it becomes? Vi sin phi. And this was V, right? I mean I. We multiplied with V. So this is Vi. This is called as power triangle. This is called as power triangle. Okay. Now, very important. For the first time, I'm defining over here. This is called as S, apparent power. S. This is called as P, true power. Vi cos phi is true power, right? And this is called as Q, reactive power. And phi is the phase angle of the circuit. And power factor will be cos phi. So from this triangle, Pythagoras theorem, what can we say? S square is equal to P square plus Q square. So what is S, apparent power, given by V into I? What is P, true power, given by Vi cos phi? And what is Q, reactive power, given by Vi sin phi? So please note down this power triangle. S is apparent power, P is true power, and Q is reactive power. And this is the power triangle for RL series circuit. Got it? How we got this? Understood? So write down what is active power. Active power will be given by, active power is what? Vi cos phi. Reactive power is Vi sin phi. And what will be apparent power? V into I. Remember the unit. The unit for active power is watts or kilowatts. The unit for reactive power is VAR or kilo VAR. What is VAR? Volt ampere reactive. And the unit for apparent power is V into A, volt ampere, or kVA. K means 10 is to 3. So please write down this active, reactive and apparent power along with the units. It's very important. They definitely ask this in one way or the other, either in the form of a theory or in the form of a numerical. Mostly numerical. Got it? Now tell me, uh, there is one more definition of power factor. Power factor is what? Cos phi, right? From this power triangle also you can calculate cos phi. Can you tell me what will be cos phi? From that power triangle by trigonometry, P by S. See, here, if I calculate cos phi, it will be P by S. Adjacent upon hypotenuse, right? So write down cos phi will be P by S, another formula. And actually, what is P given by? Vi cos phi. And what is S given by? So actually, if you divide them, you will get cos phi only. Are you understanding? Now, there is another formula for P, Q and S. Can you intelligently tell me what it will be? See, power is I square R now, but in a DC circuit. In a AC circuit, how will you write this? P as? P is I square into what? R. Q is I square into XL. And S is I square into Z. Write it down. If you have understood, you will understand this. Active power is because of resistance. Reactive power is because of the reactive components, that is L and C. So it will be XL. Agar C hota to it will be XC. And S is the total, V into I. So I square into Z. Total impedance is Z. So collecting all this information about RC series circuit, now we have to put all this information in terms of numerical and solve that numerical. Okay? Fine. So ready? I hope your calculators are there with you. Anyone having any doubt? You need to revise it again. Revise it means don't scan it. Okay, I'm giving you all the handouts. That doesn't mean that you just scan it. You need to write it down as we are writing down over here. Okay. The benefit of writing down now is whenever you see this for a second time, everything you will recollect very soon. All right. Write down this numerical number 1 quickly. You need to write it down. A coil has a resistance of 7 ohms and an inductance of 31.8 millihenry. It's connected to 230 volt 50 hertz supply. Calculate circuit current, phase angle, power factor and power consumed. If you check last, this earlier this subject was called as BEE, then it transformed into EEEE. So if you check every other paper or almost every paper, there is a numerical on either RL circuit or a coil. Coil means what? What do you mean by a coil? A practical inductor has an internal resistance that is called as a coil. Inductance is made up of coil, right? Coil also have a resistance. So whenever we call it as a coil, that means we have a resistor and an inductor. So let me draw the diagram over here. Let us understand diagrammatically what is the issue. Okay, what needs to be found out. So you have R and L. This together is called as a coil. And it is connected across a supply. What's the value of the supply? 230 volts, 50 hertz. Is the value of R given? Yes. This is R, 7 ohms, and L is given as 31.8 millihenry. Alright. So tell me, what will be Z of the circuit? What will be impedance of the circuit? Impedance of the circuit will be Z. Correct, no? Yes or no? What it will be? Z is equal to square root of R square plus XL square. Back of your mind you should know. What is current? This is current, right? If I want to find the current, this is voltage. If I want to find the current, what it will be? V upon Z. Are you understanding mentally? Okay, so that is what we need to find out. We need to find out the circuit current, the phase angle, the power factor, and the power consumed. So let's do that. Have you drawn this diagram? Please draw it fast. You have understood now what to do? Okay. So first thing is find XL. I'll tell you the flow. Always now for these numericals, you should have a clear head in finding what needs to be found first. Because what happens is I've seen many times students know the answer, know the method, but the flow is wrong. And they get stuck. Okay, so I'll tell you the flow over here, first of all, how to solve this. So first step is, first you need to find out is XL. Then you need to find out Z. Then Z will be what? R square plus XL square. Then you will find out the current. Current formula will be V by Z. Then you'll find out the power factor, phase angle. Okay. Phase angle, there are many formulas, tan inverse of XL upon R. We have written it, right? Then next, we will find out the power factor, which is just cos of phi. And then at the end, we'll find out the power consumed, which is, what are the two formulas for active power? Vi cos phi and I squared into R. Both the formulas are there, na? So this is the flow. You go from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. If you skip one step, you will not proceed. As simple as that. So let's start and find out XL. Now tell me, what is XL given by? Yes. So basically we can write 2 pi L. 2 pi FL, right? Omega is 2 pi F. So please substitute the frequency. It's 50. And what is the value of L? 31.8. Students make a mistake here also. They forget to write milli. What is milli? 10 raised to minus t. They are telling me now, but while you write the paper, you make this mistake. So calculate XL. Is it 10 ohms? Okay. Next, calculate Z. What is Z? Z square given by R square plus XL square. What is R square? 7 square plus 10 square. That is 149. So what is Z? Square root of 149. How much is that? Yeah, that's correct. Once you have found out XL and Z, what do we find out now? Circuit current I. So I will be V upon, what is V upon Z? What is V given as? 230, as it is you need to write. 230 divided by 12.21. How much is that? 84 amperes. That's correct. Others, please write along. Everyone, please write along with me. Okay. Next step is find the phase angle. And what is the formula? You can check from the analysis. Phi will be given by tan inverse of XL upon R. Right? So find out what is XL? 10, right? And what is R? 7. So find out tan inverse of 10 by 7. Is it 55? 55 degrees? Tan inverse by 10 by 7, 55 degrees. So that's the answer, correct. And after that, you find the power factor. Power factor PF is cos phi. So cos of 55 degrees is how much? 0.574. It is leading or lagging? Lagging. So please write down that. And then we'll calculate power consumed. When they ask power consumed, it will be active power. So power consumed will be VI cos phi. Both formulas you can use, I square R. You can use any formula in cross check. Use both of them in cross check. What is V? 230. How much is I? 18.84, and what is cos pi? 0.574. Calculate this. 24.87. Yes, no. Is the active power 24.87 watts? 230 into 18.84 into cos pi, which is 0.574. Anyone got that? Okay. Got it. It is 2487 watts. So I also calculate by I square R. 18 point, just checking whether both the formulas are correct or no. And what is R? 7. Is it 2487 again? If it is same, then we can use interchangeably any formula. Sorry? No. VI is S, apparent power. 248? Close enough. It depends upon if you take I in 4 digits after decimals, then it will be accurate. Nearby hai na, so we can use any formula in the exam. Okay. Now, this same numerical, you got the answers, can be solved with a Phasor algebra. I'll teach you both the methods. I'll take one more method and solve the same numerical. You get the similar answers with a different technique. So let's solve it using a different technique. So write down, or we are using a different method. We are solving the same numerical using a different method. So over here I am using blue color. So first we write in phasor form. What is V given by 230, right? How will you represent in phasor polar form? 230 angle 0. What is Z? R plus J XL, right? We have calculated XL now. What is R? 7 plus 10 J ohms, correct? Now if I convert this is rectangular form, right? If I convert this into polar form, convert it please. 7 plus 10J. You understood now how, I mean, you have forgotten. I hope you have not forgotten how to do it in calculator. Shift, what you will press? Polar. In calculator, shift polar 7, 10. How much you got? 12.20 angle. And what is the unit? What's the standard form over here? Z is Z angle phi. ऐसे लिखते हो ना? Yes or no? Now, so over here I directly get the phase angle. What is my phase angle over here? 55 degree. Got it? How will you calculate the current? Current vector will be voltage vector divided by Z vector. So 230 angle 0 divided by 12.20 angle 55 degrees. So what will you get over here? 18.85 angle minus 55 degrees. Why minus sign? Because it is lagging behind the voltage. Got it? वही आया था ना हमें 18.85 amperes. Sixth is power factor cos phi, cos of 55. So that is same as 0.574 lagging. And 7 will be power consumed. It will be VI cos phi, which is nothing but 2487 watts. Got it? That's it. So we have solved the same numerical using Phasor algebra. Understood? Yeah? Okay. Now we move on to the next one. This is for your reference only. There is a numerical below. Or as what happens if it is a space, now you all understand that the PDF is over. Correct? Okay, write down this numerical. Note it down, please. Find small r and capital L. Small r and capital L is a coil, and coil have an internal resistance small r, and there is a resistance R, pure resistance R also connected of value 10 ohm. The voltage across that resistance is VR, which is 20 volt, and voltage across the coil is 20.4. You all can view it clearly, na? Yeah, clear, na? Yeah? Okay. All right. Which reactive power? What do I explain there? Yeah. Okay. Wait. Just wait. You till the time they note it down. You refer that power triangle. See, it's a vertical component, right? Vi sin phi. So if I take Vi cos 0, so I'll get V into I only. बराबर है? So your apparent power becomes same as true power. But if I take Vi sin phi, sin 0, मतलब phi is 0, so what will I get? Sin 0. Now, if I go on increasing the value, let's say Vi cos 30, that will be a positive number. Same thing with Vi sin 30 will be, yeah, you understand? You can calculate sin 30 and cos 30, or sin 90 and cos 90. What is cos 90? 0. And sin 90, 1. So normally we go for a power factor of 1. We want a power factor of 1. So what do? We reduce the height of Vi sin phi. So that's a reactive power. We don't want that, but it's required. So what happens is capacitor charge and discharge in one cycle, and it discharges in another cycle. Same with the inductor. Inductor stores energy in the form of electric field. So it stores the energy, and next half cycle it releases the energy. So on average, the power consumed will be 0. But it's there, it's circulating power. We cannot, we can reduce it, we cannot eliminate it. And how do we reduce it? By making phi smaller and smaller. See, cos 90 is 0, but cos 0 is 1. So if I reduce phi, I am increasing my power factor. And if I reduce phi, what will happen to sine? Vi sin phi, it will become smaller and smaller. And if it becomes smaller, see, this is my power triangle. My base is my Vi, right? This is Vi, this is Vi. This is what? Vi cos sin phi, and this is Vi cos phi. So if I reduce the power angle, what will happen? This will reduce. And the difference between Vi and Vi cos phi will be same. Actually, ये है, this and this should be matched. Okay, that's the extra part. But we cannot help it, it's required. Now, how will you solve this? Yeah, everyone? What's the clue? Acha, tell me from here, what is V coil? Now, please understand, you need to answer this because we have done the analysis for RL series circuit. What is V coil? I into impedance of the coil, right? Impedance of the circuit, the impedance of the coil. What is VR? I into R. And what is total V? I into Z. Total. But here required, this is not required yet. Now what will you do with this? How will you find further things further? We need to calculate small r and L, capital L. So what's the flow over here? So what you will do is, I'll write it down over there. So first thing, you can also note it down, this is the flow. Okay? So in the back of your mind, you will first calculate I. How will you calculate I? VR upon R. See, VR is I into R, right? So I will be VR upon R. Second step will be, you'll calculate Z coil. Z coil will be V coil upon I. Got it? कैसे है? V coil is I into Z coil ना? Then you will say, सुनो, then you will say what is Z coil? Square R square plus L square. Got it? Yes or no? Now tell me what will be total Z of the circuit. Total Z. Total R upon, ये देखो ऐसे होगा, R plus R square plus ये सॉरी ये L नहीं है, XL square है, plus XL square. Got it? ये समझ में आया? How it is R plus R square plus XL square, total resistance multiplied by total inductive reactance square. Got it? So if you compare these two equations 3 and 4, you will get two unknowns are na, R and L. So you'll calculate R and then you calculate L. Okay. So once you get the value of R, you can get the value from here, from these two. Okay. From 3 and 4, you will get R. And once you get the value of R, you'll get the value of L. And once you get the value of L, that's the end of the story. Now, how will you calculate total Z? Oh, by the way, I didn't tell you how to calculate total Z. Step number 5. How will you calculate total Z? Total V upon I. Got it now? Total voltage upon total current is impedance of the circuit. So from here, you'll calculate Z. This is the flow. I mean, I told if you do this, you will get the answers. So let's start solving. Rather than showing you all this, let's start solving. So write down solution. Step number 1 is VR is I into R. So circuit current will be VR upon R. How much is VR given as? 20 volt. And how much is R given as? 10. So this is 2 ampere. You don't require a calculator to figure this out. Got it? Next is, what is V coil? Voltage across the coil given by I into Z coil. So what is Z coil over here? V coil divided by I. How much is voltage across the coil? 20.4. And how much is current? Just now we calculated 2. So how much is this? 10.2 ohm. Are you following? If you are stuck anywhere or not understood something, please let me know immediately. Yeah? Because now we are in the mode of solving. So now next, what is Z coil? Square given by R square plus XL square. Okay? And actually, if we write Z coil, it will be square root of R square plus Z square, and that is 10.2, right? So if I write in terms of square, Z square, you can have to write it as 10.2 square. समझ में आया why 10.2 square? So write down over here, that is how much is 10.2 square? Okay, let it be like this only. 10.2 square. Call it equation number 1. Are you following? Yeah. Next, step number 4 will be calculate Z. What is Z? V given by I into Z. Alright. So what will be Z now? V by I. How much is V? 36. And how much is the current? 2. So what it will be? 18 ohms. Got it? Now, what is total Z given by? Total Z. Z square. So in this circuit, we have R, small r and L. So R and R will get combined. It will be R plus small r square plus XL square. So how will you write it over here? Z square will be capital R plus small r square plus XL square. Did you got it? Did you get it? Understood how we have written this formula? So please now write it down. Similarly, this will be 18 square is equal to, this is R is 10 now, R is 10 plus R square plus XL square. Call it equation number 2. Now, next step is equation number 2 minus equation number 1. If we do that, what do we get? I mean, I'm subtracting this equation. So what do we get? 10 plus R square minus plus XL square minus R square minus XL square, right? And that is equal to 18 square minus 10.2 square. Let me expand this. Okay. So what do we get over here? R square gets cancelled. XL square, this you open it up, it will be 100 plus 10 square plus 20R plus R square, right? XL square already got cancelled. And this will be R square minus R square. How much is this? 219.6. Just check. So here in the next step, R square gets cancelled. So 20R will be 119.96. Are you getting these answers? So calculate R. It's 6 ohms approximately. Is R equal to 6 ohms? Nearby. Got it? Okay. So this is how you find out R. Now what we need to find out? L. How will you find it out? Tell me which equation you will use from equation 1. Can we rewrite equation 1? What is equation number 1? R square plus XL square is equal to 10.2 square. So let us write it down. R square plus XL square is equal to 10.2 square. What is R square? 6 square plus XL square is 10.2 square. So XL square will be 10.2 square minus 6 square. That will be 68.04. Calculate XL. 8.25 ohms. Please check this answer. Got it? How will you find L now? Very difficult. What is XL formula? 2 pi FL. So what is L? XL divided by 2 pi FL. So 8.25 divided by 2 pi into, what is F given as? 60. 60 now. So calculate this. 8.25 divided by 2 pi into 60, that will be 0.022 Henry. That is the answer. Okay. So yeah, that's all for this lecture. And since we have a lecture next week now, solve this numerical. I'm not telling you to note it down. Try to solve this numerical on your own. Is little bit at a higher level than whatever we have solved. So solve this numerical number 3. This is for home assignment. Remember, by the time by the time I'll upload this handout, I'll also upload the solution. But try to solve this on your own first. Okay, and then cross-check the answer. The clue is we need to draw the phasor diagram, and to draw the phasor diagram for such kind of a circuit is challenging. So please go through the solution. If you have any doubt, you can tell me. So that's it for this lecture.